We are now going to zoom in to that edge of the medulla and cortex and look at a nephron and collecting duct system. And I'll tell you what these are. Remember, we have our afferent arteriole and our efferent arteriole, both arterial, so oxygenated blood, but we're going to have something in between where filtration is going to occur. We're filtering the blood so it can go into the nephron and either become urine, form urine. In between these two arterioles is what's called a glomerulus. It is a highly fenestrated capillary bed where filtration occurs. We will look at it more closely later. So surrounding that glomerulus is going to be the first section of our nephron. I'm going to draw the nephron in blue. This that I'm drawing right here is our glomerular capsule, also called Bowman's capsule. And this whole structure together is called a renal corpuscle. Oh, what color? Decisions. No, I don't want pink. I'm going to do green because I'm not going to use that again later. So this is our renal corpuscle that you'll see in lab on the histology of this. And you're kind of seeing the whole thing. It's made up of the glomerular capsule and the glomerulus. So this is where filtration occurs, which we'll of course look at in more detail. Once the filtrate has formed, it's going to enter a whole series of tubes that make up the nephron. The first tube is the proximal convoluted tubule. Convoluted tubule. Convoluted means twisted, right? And it's proximal to where filtration occurred. We're then going to have a nephron loop. It's going to dip down, have a thin portion and a thick portion. Dip. Oh, I don't like that. Thin and a thicker portion, and then form the distal convoluted tubule. I'm just going to write DCT, distal convoluted tubule. And here's our nephron loop. From the distal convoluted tubule, we are going to enter the collecting duct system. That is not technically part of the nephron, but is continuous with it. From here, what is going to be urine when it exits here is going to enter those calyces and then the renal pelvis and then the ureter. This is urine. So to go from blood to urine, we're going to have a whole lot of steps occur to this filtrate. We're going to have some things that exit that filtrate and enter the blood again. So we basically dumped things into this nephron. We're going to reabsorb some of those things. Not necessarily just right here, just generally. That means back into blood. We're also going to have some things that we put into the nephron that we didn't before. This is going to be called secretion. So the composition of the filtrate is going to change throughout this entire set of tubes, and then also be able to be regulated depending on environmental conditions. This will be a topic of the next 2 weeks, going through these tubes. This week we'll actually talk about filtration. We won't talk about the rest of the tube until next week. Of course, there is more than one type of nephron. And those differ depending on how far down the loops dip into the medulla. So in this image here, we've got the cortex and the medulla of the kidney. And then we've got nephron loops that are short. So these nephrons would be called cortical nephrons because they're mostly in the cortex. Then we've got nephron loops that dip way down. This is a long nephron loop. This is going to be important for creating an osmotic gradient. So when we look at this nephron loop, we'll see the importance of this. This is called a juxtamedullary nephron. This is actually only about 15%, but they're responsible for creating an osmotic gradient in the medulla that's going to be important for blood volume and electrolyte regulation. Down here, this is a calyx. Okay, along with the different nephrons, there's different blood vessels that surround each of these. So this is going back to those terms, the peritubular capillaries versus the vasa recta. That efferent arteriole either connects to peritubular capillaries, which surround cortical nephrons. They are very closely adjacent to all the tubes, and we're going to look at what happens in terms of reabsorption and secretion in that location. The efferent arteriole from juxtamedullary nephrons is going to connect to a vasa recta. These are blood vessels that surround a long nephron loop. So they arise from the efferent arterioles and run parallel to these long nephron loops.